In fact, you typically need somewhere between 40 and 50. And so trying to decide what's the important stuff at the beginning is an incredibly important decision. And it isn't just the coder who decides it. The designer has to participate in this. Right? He's got to figure out how the game starts in order for this to be interesting and to work well. Again, classic example of this is Skyrim. You start in a very little town in Skyrim. You know, you're on the cart. You get pulled in. You're going to get executed again. Everybody notice every Elder Scrolls game you're in prison or been accused of some crime you didn't actually do. Anyway, they're going to execute you, and it's going to be really bad. And a dragon shows up, and it saves your bacon. And you run around through the town. But all the assets that you need are just the town assets, the dragon, whatever people and bodies that went with that, and then the underground piece that eventually gets you out of the town. And while you're playing that hour to 2 hours of that 2 to 3 gigabytes of content, all of the rest of this stuff is installing in the background. Right? That makes for a really great player experience. And so that's what we've been encouraging people to do. It's still not an easy problem to solve, and we have a ton of tooling and work that we need to do to make this easier for game developers, which is what a lot of what my team is going to be responsible for, making sure happens going forward. This is a lot harder for open worlds than it is for more compartmentalized worlds. But the key to this whole slide, really, at the end of the day, besides the game design pieces, is compression. Compress everything that is on the hard drive. Everything that is on the hard drive. Because it is way easier, faster, better to read a small block off that hard drive and decompress it into RAM than it is to do anything else. That hard drive is not fast. It is cheap, but it is not fast. So anything you can do to get the stuff off the hard drive and into RAM as quickly as possible, and then use one of those other cores you're going to get as a game developer to uncompress it, is worth it. The connect you can actually count on being there. Okay? What does that mean? As we started to think about this, we realized that we live in a world today where Connect can actually be watching me even when I'm using a controller. So what did that mean? We had a team that worked that was called the Fish team that decided to prototype this in a first-person shooter and come up with some neat ways that Connect could do this kind of stuff. And the way that they came up with it that was so incredibly cool was a whole set of different gestures that augment what you're doing with the controller. They don't replace the controller, but they make it a more immersive experience. They make it things that you would do anyway as a player, so that you can have a much richer experience than you would by just button mashing and moving the thumbsticks around. First thing we did was we realized that, wow, we actually have a third thumbstick here. Because if I lean, wow, hey, this is just a giant thumbstick. So we do that. You can ask for thumbstick number 3, and it will tell you which way that particular user's body is leaning. Okay? No, you don't have to write any magic code at all for this. Right? It's just, what's the thumbstick doing? Done. You win. Right? That's one way you can augment it. The other way that they thought that would be interesting to augment it is, one of the most annoying things that you have to do in a game, especially on a console, is deal with the fact that you've got like 4 buttons, 2 shoulder buttons, you know, the 2 triggers, a couple of thumbsticks, and then the D-pad. And what everybody uses the D-pad for typically is for some kind of menuing system. Right? You hit some button that brings up the menu, and then the menu lets you pick all the stuff you want to do. If you're playing Skyrim, again, you're like, menu, that spell. Right? Nothing breaks the illusion of being in the world more than pausing the entire game while you try to find a potion you have to drink, or you try to find some magic thing that you're going to turn on that's going to help you get past this guy. Right? These guys came up with the most brilliant thing I've ever seen, and every time we demoed this to game developers, there were gasps in the room. But basically, you're playing along, and you eventually come to a wave of bad guys, and the bad guys are essentially invisible. They're very, very lightly drawn. You can't really see them very well. If, while you're playing with the controller, you tap your forehead and go back, you turn on X-ray vision. If you tap it again, the X-ray vision turns off. Okay? Now it's no longer, I need X-ray vision. OK, menu, down, down, left, left, up, up, that one. It's, yeah. And we're done. I'm playing with X-ray vision. OK? Completely different experience. So then the question became, OK, well, how did they code that? Well, for those of you who've done any kind of Connect work, you realize we have a visual gesture builder, and we realize we have all the skeletal tracking data. And we asked, because I kept getting this question over and over again, was just like, yeah, but I mean, how hard is it to make that happen? And so I started asking them, well, what would you do? Well, I have all the skeletal tracking data in 3 space. I would probably figure out that the arm was moving up and then try to, yeah, you're way overtaking the plumbing here. There's a lot of data there, but that doesn't mean you have to use all the data that's there. This is a common problem people have whenever they do anything with computers and code, right? You want to use all the data that you got. You don't need all the data. The only data I need is I have a node that tells me where my hand is, and I have a node that tells me where the center of my forehead is. And once these get close enough, and this one is slightly above this one, you did it. You touched your head. And this turns out to be meaningless. It doesn't matter. But it doesn't matter because nobody is going to play with it to figure out, like, does that work? Does this, right? They're going to do this because you told them to do this. Right? The player is your friend. He wants to believe. So it turns out that there's a really simple way to implement this, which we did, and it was magical. Right? And there was almost 0 latency. You would do this, and it would instantly turn on. And people were stunned. They were like, my God, Connect had so much latency before. How did you guys fix all this? Right? Well, it's because we did. It runs at 30 frames per second now. You get a new data set every 30th of a second telling you exactly what that player has done. Okay? Body motion that we've already talked about, but you can also point. Right? It knows my arm's out. It knows I'm pointing because it can detect this, it can detect this, and it can detect that. So my hand can be in 3 different states, so it knows I'm pointing. So we'd ask them, OK, well, wouldn't it be great if you could point into the screen? Right? You got a whole bunch of enemies you got to kill. You can't shoot them all. They've got some magic power that keeps that from happening, so you need to call in an airstrike. In order to call an airstrike, I need to select them all. So I start selecting everybody on the screen, and then I do a voice command. Fire missiles. All these missiles fly in, blow these guys to pieces. Yes, perfect. Right? Then we ask them, OK, well, how would you implement this drawing into the screen? Oh, well, first we'd have to calibrate, right? I got to do the corners, and then I got to, aim, and I got to look down my arm. And I'm like, really? Could you just humor me and play this demo for a second? Right? And they would play the demo for a second, and then to go like, oh, well, you didn't do that at all. No, because you don't want to have to calibrate. You don't want to have to think about it that way. In fact, the only thing you have to do is point your hand out like this, have the Connect arbitrarily pick someplace on the screen that is, and then start moving. And as soon as you move, you instantly calibrate it in your own head. You know exactly where you're pointing. You know exactly what's going on because the little cursor starts to move with your hand motion. And you don't have to calibrate anything. It just works. And as long as that cursor passes over somebody, guess what? You selected them. That turns out to be a trivial 2-space collision problem. Right? All of these kinds of things turn out to be ridiculously easy to do with the Connect today. And it's there already. And the punchline of the whole thing is you've already paid for it. We're already taking away CPU and GPU in order to have this thing work properly. So we've been strongly encouraging people to be able to use this stuff. And that demo has probably gone further than anything else that we've done to try and impress people with that. So this has been the whirlwind tour of getting stuff running on Xbox One. This talk originally started, like I said, for the ID at Xbox folks. In order to get through it in any kind of reasonable amount of time, unfortunately, we can't do any large detail stuff. But the good news is that as the platform continues to move forward, as we get more and more dev kits out to people, as people start to think about how to be able to do this from far beyond just a gaming perspective, this will become more and more open and available to you guys. So thank you very much for this. It was awesome. And I have like 2 minutes and 40 seconds left, so if someone else wants to ask a question, they can. Can we get the middle mic turned on? Is it on yet?
Am I on? Okay.
Yeah, there you go.
Yeah, I want to ask you, I kind of understand as far as the way the different optimized VMs. Are there any plans for an emulator for the 360 games?
There are, but we're not done thinking them through yet, unfortunately. It turns out to be hard to emulate the PowerPC stuff on the x86 stuff. So there's nothing to announce, but I would love to see it myself, too. So thanks. Yes?
You mentioned the exclusive partition having the Win32 API set as well in it. Does that imply that once Threshold comes up, that any Windows 8 game will be able to run in that exclusive partition?
Yeah, actually, they can today.
Pre-compiled?
Pre-compiled, no. You'd have to compile them for that partition. Okay. But in the Threshold time frame, I think in Threshold time frame, you'd still have to recompile it because we have different DLL signatures than the rest of Windows does, and we need to line those up to make sure that you don't call some virtual function and get the wrong entry. But yeah, once you recompile, I mean, the ideal scenario for the Threshold time frame is, I don't know how much they've shown of this, but having like the Visual Studio where you just pick which platforms you're targeting. And one of those platforms will absolutely be Xbox One. So.
That would assume that you're using DirectX and not OpenGL?
Absolutely, yeah, for today. In the lean and mean partition side especially, we're actually going to put DirectX 12 in there as quickly as we can as well. In fact, all the extensions for D3D12 we're going to do on Xbox One in the DX11 that's there to sort of vet and prototype them all. And then once D3D12 is baked, we're going to move it into that partition whole on and then probably actually deprecate the D3D11 stuff above and beyond just being able to run the older games. So, thanks. All right, thank you very much, everyone. Awesome.